Hello guys, so let's talk about the Can-Ingold-Prelog system. Now, if you've not watched the part 1 of this series, please make sure that you watch it so that you won't miss out of what we did in part 1 and for better understanding of what we are going to be doing here. Now, if you look at this structure given to you, how do you determine the one that we have the highest priority, and how do you determine if it is arrow or X? Now, the software I used to actually draw the structure has given us the answer that this is what arrow configuration. But why is it arrow and not X? That's what we are going to know now, or we are going to determine. Now, whenever you are given a compound like this, the first thing you need to do is what? Assign priority according to what Can-Ingold-Prelog said. Now, when you assign priority, according to atomic number. According to atomic number. Now, the one with the highest atomic number, the one with the higher atomic number is the one that have the higher priority. And then the one with the lower atomic number is the one with the lower priority. Now, notice something, that hydrogen is usually the one here on top of this bond here that is leaving. This bond here is telling us that it's going away from us. And the lower priority group is usually the one on top of here. While the higher priority group is usually the one that should be here. So if you have it in this way, all you need to do, first of all, before you even start assigning priority, is to change the position of hydrogen to here and that of this to this position. Are you getting it? You change the position of hydrogen to here, to this position, and this OH to this position. So if we want to do that now, how will it be? We have to redraw the structure again. The structure will now be this, and then let me make it the way it ought to be. We have the bonds that join, then this one is the wedge, then this one is a straight line bond, and this one is what? Straight line. Now, I told you that hydrogen is usually the one here. Then what should be on this one? The one with the higher priority. We are supposed to know the priority first, but I'm just giving vague idea now. So what will be here now? CH3 should take the place of this one. Then we now have what? CH2, CH2, CH3. Now, which of them have the higher priority? If you look at here, what do you have here? Carbon, oxygen, carbon. Now, between oxygen, carbon, and carbon, which will have the higher atomic number is oxygen. So oxygen will be carbon what? It will be number 1 according to the priority system. Is that okay? Now you have carbon and carbon. Now when you look at them, this is an alkyl group. This is what 1, 2, 3 is propyl, and this other one is what? Methyl. Now when you have two, we look at them, and you have two, what is it called? Two hydrocarbons or two alkyl group attached. The one that is longest is usually the one that have the what? Higher priority. So in this case, between propyl and methyl, which is longest? Propyl. So propyl will be what? Number 2. Is that okay? And then finally, this one will be what? Number 3. And then hydrogen will be what? Number 4. Is that okay? So we come here and say this is number 1. This is what? Number 2. And this is what? Number 3. So what configuration is this? If it is going from here to here. Now, according to Can-Ingold-Prelog, if it is going from right to left, what do you call it from? I mean, if it is going clockwise, what would you call it? You call it what? Arrow configuration. Is that okay? If it's going clockwise, you call it what? Arrow configuration. Now, please make sure, if they give you something like this, you must make sure that this hydrogen is the one here, and the highest priority group must be the one on this wedge. Is that okay? For you to determine the configuration. If you rush and just assign priority like that, or just draw your line anti-clockwise, you are going to fail. Like this one now, if we want to draw the way it is, it will be what? 1, 2, and what? 3, which is this way, right? If it goes this way, what do you call it? Anti-clockwise. So this one, the way it is like this, you say this is what? S. But the main configuration, according to Can-Ingold-Prelog, is what? Arrow. So you must actually arrange these ones where they should be. First of all, assign the priority. Then you now know the one that is higher priority and the one that is what? Low. The higher priority group must be on this one that looks like triangle. While the lower priority hydrogen must be on the one that is what? Dotted, broken lines. Hydrogen must be on that. Is that understood? So let us go to the next. you have this. Use the arrow and S to assign priority to this. Now in this case, what do you have? You have carbon. After carbon here, what do you have? Oxygen, oxygen. Is that not so? That is so. Now this hydrogen here, is it on the higher priority group? Yes. Are you getting it? The hydrogen is on the higher priority group. Now how about this one? CH2OH. Now if this, hydrogen is on lower priority group, rather. It's on the dotted line, so it's on the lower priority group. So here will be what? Carbon. Is this one carbon 1 or carbon 2? This cannot be carbon 2. You have to consider between carbon, hydrogen, oxygen, and carbon, which one will be the one that have the highest atomic mass, atomic number? Oxygen. So this one will be what? Number 1. So the next question now is the higher priority group on this one that looks like triangle? Yes. And then which of them do you think will be carbon 2? Which of them will you think will be number 2 according to priority? This one you have carbon. Here what do you have here? Carbon. Can you use carbon and carbon to densify? No. If I want to bring this out, I'll bring it as carbon H. This H here means there's another H here. Then we have what? OH. Why this one here is what? COOH. Now you use carbon and carbon. Can carbon and carbon densify? No, because they are the same. Now you now go to the next atom. Oxygen and hydrogen, which one have the highest? Oxygen. So here will be what? Number 2. Is that understood? And finally, here will be what? Number 3. So what direction is it going to? Is it not coming from number 1, 2, 3? What is this? Is it clockwise or anti-clockwise? Clockwise. Is that so? This clockwise. Coming from 1 like this is clockwise. Are you getting it? So this configuration is what? Arrow configuration. Is that okay? Arrow configuration. Now how about this? Look at the way they now orient it. Look at the way they now orient it. This is what? 1. This is what? Okay, this is not 1. This is carbon 1 here. Or let's not be calling it carbon 1. My mind is always carbon 1. This is position 1. And this is what? Position 2. And this is what? Position 3. Of course, hydrogen is position 4. While you are counting, you don't count hydrogen as part of them. Are you getting it? So this is 1, 2, and 3. So in what direction is it going? Anti-clockwise. So that is why they call this one what? S configuration. Is that okay? S configuration. Now let's look at another. These are test questions. These are test questions. Draw and specify arrow and S enantiomer of the enantiomer of, or what did I write? Draw and specify as arrow and S and the enantiomer, if any, of the following compound. Let me look at it again. The question says draw and specify as arrow and S the enantiomer, if any, of the following compound. So you draw and specify as arrow and S and then the enantiomeric form of it, if any, of the following compound. Now what we are going to look at it is the first one is 3-bromohexane. Now what is the structure of 3-bromohexane? First of all, we have to draw hexane. Write hexane. Hexane is what? CH3, CH2, 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 then what? CH2. This 1, 2, 3, 4, 5, CH3. Now at position number 3 there is what? Bromo group. 1, 2, 3. So we erase one hydrogen, this one from here, and then we'll pull bromine. Is that not so? Now if you want to put this in 4 dimension, in 4 or tetrahedral structure, what will it be? It will be C. Then this group here, what do you have? CH3, CH2. What do you have up here? B arrow. Is that not so? What do you have under here? Hydrogen. Then what do you have to this side? CH2, CH2, and what? CH3. If you look at this very well, this hydrogen is the one under. Now look at them. Are there 4 groups around this particular compound? Are there 4 groups around it? 4 different groups. So it has a chiral carbon center. Is that not so? Now we now bring it out. Let me bring it out to a new page so that we will not confuse model of the whole something. We have CH3, CH2, C, this B arrow, this is what? H, and here is what? CH2, CH2, CH3. Now let us assign priority to each of them. Let's assign priority. If you assign priority to this, what would you think it will be? Which of them will be carbon number 1? Between carbon, of course, we know that each of these ones have, this is a carbon atom here. This is a carbon bonded to this carbon. Is that also? Now, this is what? Hydrogen. When you see any bond like this, note that this carbon is not, if I want to bring this one down, now I can say this is carbon. CH2 is what? Hydrogen or what? Hydrogen. To make it easier. Are we getting it? Now, this is the chiral carbon. This is the one that we are looking at. Let me represent it with C. Now, this chiral carbon that is here, it has 4 different groups around it. Now, this group here, Br, bromine, and this is another group here, carbon. Then this is another group here, carbon and hydrogen. Which of them have the highest priority? Is it bromine? Is it carbon, or hydrogen? Is what? Bromine. So here we want number 1. Now, between these two carbon, this group is what? CH3, CH2. Why this group is here what? CH2, CH2 are what? CH2 are what? CH3. Which of them do you think, this CH2, 3 here. Which of them now do you think would be the one with the highest priority? I told you that the one with the longest chain, right? So here will be what? Number 2, and here will be what? 3. So how do you call this now? What structure is this? Is it S or arrow? Arrow. So what would be the S form of it? Because they say you should draw the enantiomeric. If it is arrow, it means that the enantiomeric form will be what? X. Now, how do we represent this now? You don't draw it like this. You must show the wedges. Are you getting it? So in this case, we can say this is this. Now, which of them is this way? The one that have the highest priority is this, right? So according to the way it has been arranged here, it can be anywhere. So let's put it anywhere. We can say the highest priority group is this, and let's position it here. It will be represented with this B arrow. Is that not so? Then this one now is just there, which is what? CH3, CH2. Now, how do you represent hydrogen? Hydrogen is what? Dotted line, hydrogen. Are you getting it? Then this other one is what? Is also just like that, which is what? CH2, CH2 are what? CH3. Is that understood? Now, this number 1. This is what? 2. And here is what? 3. I will say this is what? Arrow form. Now, what do you think will be the mirror image, which is the S form? The S form now will not be just opposite of what we have here. You carry this one to this side and bring this one this way. Is that understood? So you have something like this, which is the mirror image. Here now will be what? CH2, CH2. Okay, this is CH3, CH2, CH2. Then what are we going to have here? This same B arrow. Now, in most cases, it's expected that this B arrow should be under, but you can still draw it like this. It's just showing to you. Are you getting it? So this B arrow, then what do you think we will now have here? CH what? 2. Then what? CH3. Then what do you think? Now, see the way I will draw this one. You saw this first one. It was facing what direction? This direction. So this other one now will be what? Facing this direction. Okay, let me put it where. This one now becomes something like this. And then you would put the hydrogen. So this is what you're expected to do in that question. Now, the next one is 3-chloro-3-methyl pentane. Let's draw the structure of 3-chloro-3-methyl pentane and see how it is. Pentane is what? CH3, CH2, CH2, CH2 are what? CH3. Is that not so? Now the question says 3-chloro-3-methyl pentane. Is that not so? So we come to 1, 2, what? 3. Our position number 3, what do we have there? Chloro. Are still the same position, or let's put the chloro under. What do we have here? Chloro, right? So chloro. At this position number 2, what do you have here? Methyl. Are you hearing it? Now, the way it is like this, is this one, do you think it has a chiral carbon center? Does it? Look at it. This group is the same with this group. Is that not so? So does it have a chiral carbon center? Does it? No. And since then, it does not have. So this one does not have a chiral carbon. You just leave it like that. Is that okay? Now the next one is 1,2-dibromo-2-methyl butane. 1,2-dibromo-2-methyl butane. Let's draw the structure of 1,2-dibromo 2-methylbutane. 1,2-dibromo. We have 1, 2, 3. This is 4 butane, right? 1, 2. So it means that we have bromine at position number what? 1. Is that not so? And at position number 2, we also have another bromine. So remove one hydrogen from here. Sorry. This is supposed to be bromine. Then what other one again? Is 1,2-dibromo 2-methyl. So at position number 2, we have what? Methyl. Which was CH3. Now I want this bromine to come down because of stereochemistry. This is what? CH3. This is what? Br. So that the wedge structure will be under. Like I said earlier, that the wedge structure should always be under for it to fit well, because it's like the support. So bringing it up now, it means you are turning the structure upside down, like what we did for this one. So the ideal way, or the ideal thing we are supposed to do here, is bring this structure down to face down. Are we getting it? So that is that. Now let's look at this together. If I want to put this together now, I would say this structure is the same thing as Br CH2, so that we have CH3. Then what do we have here? Br. Then what do we have here? CH2 CH3. It's still the same thing, right? Now the question now is, does it have a chiral carbon center? And if yes, where is it? That's a chiral carbon center. Is that not so? This is it. This is a chiral carbon because there are 4 different groups around it. Is that understood? Now, how do we now ascertain the one that have the highest priority? Which of them do you think has the highest priority? Which? Bromine, right? 1. Now, between these two, which of them do you think will have the highest priority? This one, right? Why? Because this is CH2. This is CH2. Then after this CH2, what do they have here? Carbon. Why after CH2, what do they have here? Bromine. So here will be what? Number 2. And of course, between these two, which of them do you think will have the highest priority? Which one? This one, right? Here will be what? Number 3. And here will be finally what? Number 4. So if you want to arrange it now, what will it be? To be something like this. Abina. Then what do we have? You have, we can use dotted line to show that this one is coming up. Then what do we have here? Just a group and another group. Is that not so? So the way it is like this, what will be here? CH3. Is that not so? And what will be here? Br CH2. And then what will be here? CH2 CH3. And then what will be here? Br. Now what enantiomer is this? 1, 2, 3, 4. This is going like this. Is it clockwise or anti-clockwise? So you see, this is what? Arrow configuration. Now the enantiomer of this other one now will be what? S. Are we getting it now? So how do we draw the S structure if this one is arrow? The S will be what? Mirror image. Is that understood? Now what do we do for the mirror image? Bring this one here and take this one here. That is the only difference. So we still have our CH3 on top. In what direction will they be facing now? This one will still, this one now will be what? CH3, CH what? 2. And then here will be what? B arrow, CH2. Then this other one will be facing this direction, right? And here will be what? B arrow. Is that understood? So that is that for this one. So this is the mirror image, the enantiomer, and this one will be the what? S configuration, and this is what? Arrow configuration. Now the next one is we have 1,3-dichloropentane. Let's look at it together. 1,3-dichloropentane. Now pentane is what? CH3, CH2, CH2, CH2. Then what do we have here? CH3. 1,3 dichloro. Meaning our position number 3, what do we have here? Chloro group, right? Our position number 1 rather. We first of all have 1 chloro group. Is that not so? Now our position number 3, you have another chloro group. So remove 1 hydrogen from here. Put chloro group. Now let us draw this and see if we can. Can we see a chiral carbon center from here? Can we say that this is a chiral carbon center? Yes, let's put it together. This is what C. Here's what Cl. Here's what. Okay, let the Cl come down. Here's what hydrogen. Here's what Cl. Then here is what CH2, CH3. Then here is what Cl, CH2, CH what 2. Is that understood? Is that understood? Now, have we gotten this? What do you think is the next thing for us to do? Ascertain the one with the highest priority. Now, men looking at this, which of them do you think will have the highest priority? Chlorine, right? So chlorine will be number what? 1. Which of them will be number 2? This. Yes. And which of them will be number 3? This. And this will be what? Last. So we come here and draw the structure, the wedge. So this will be something like this. Here is what? Cl. What do you have here? Hydrogen is coming up, right? So we'll break it down with hydrogen. Are you getting it? Then here will be what? Cl, CH2, CH2. And then here will be what? CH2, CH3. This will now be the structure. Now the question is, what configuration is this? If here's 1, 2, 3, in what direction is it going to? Clockwise. So what do you call it? Arrow configuration. So of course, from this arrow configuration now, you can now call it, you can now what? Name or call the Z. Now in most cases, you just put arrow, then you now call the name of the compound. Like this case is 1,3-dibromo pentane. So you can, don't just put arrow configuration, put arrow 1,3 dibromo, dichloro rather. Dichloro what? Pentane. Don't you put arrow configuration. Is that understood? Call the name of the something. Now, this is arrow configuration, and then we move further. What will now be the enantiomer? To now be the what? X. So this one will be something like this. Then this one will come here. What happened? This one comes here to give us what? Cl, CH2. Sorry, it's supposed to be CH2, CH2, Cl. And then what do we have here? CH3, CH2. And then finally, in what direction? This one is, I didn't specify the direction. This one, if this one is facing this way, it means that this other one will what? Be facing this direction. Is that understood? Cl. So that is that for that question. Let's look at the next. The next one is 3-chloro-2,2,5-trimethylhexane. 3-chloro-2,2,5, 5-methylhexane. 3-chloro-2,2,5, 5-methylhexane. What is hexane? CH3, CH2, CH2, CH what? 2, CH2. These are many. 1, 2, 3, 4, 5. And here is what? CH3. Now, what do you have in the question given to you? 3-chloro-2,2,5-trimethyl. So we go back and say 3-chloro-2,2,5-trimethyl. Okay. 3-chloro-2,2,5. So this is 1, 2, 3. So our position number 3, what do you have? Chlorine group. Are you getting it? 2,2,5. Which is this? Up and down. You have what? Methyl. 2,2,5. Position number, this 1, 2, 3, 4, 5. Position number 5, you have another what? Methane. Methyl group. Are you getting it now? So this one now, hydrogen is not supposed to be here again. So this becomes CH3, C, CH3, CH3. Then we have C. This is what? H. And here is what? H. Then what do we have here? C, H2. Then we have CH2. Then we have C, H. Then what? CH3 and what? CH3. Now the question is, which of them is the chiral carbon center? Can we say this is the chiral carbon center? No. Contains 3 different groups. Now can we say that this chiral carbon center, these 2 groups are what? The same. Can we say this is the chiral carbon? No. This one has 2 the same hydrogen. How about here? Can we say that this is also a chiral carbon center? Huh? Yes, supposed to be chlorine group, not hydrogen. So it's supposed to have chlorine here. Now, can we say that this is the chiral? No. How about this? Can we say this is chiral? Yeah. This group is different from this group. And this group is it different from what we have here? Huh? Yeah. It's different. So this is a chiral carbon center. Is that not so? This is chiral carbon center. Now let's make things easier by assigning priority. Which of them do you think will be the one with the highest priority? Is it chlorine? Yes. Chlorine will be number 1. Now between this CH3, CH, which of them do you think will have the highest priority? Tertiary we have highest. Are you getting it? Because after carbon here, what do you have? Another carbon, another carbon. Why this one? After carbon here, what do you have? Hydrogen. So here will be number what? 2. Which of them do you think will follow? This, number what? 3. And finally here is what? 4. So if I want to represent this now, I can say this is C. To make things easier, I can say this is C. This is what? Hydrogen. And here is what? CH3 bracket what? 3. Then what? C. Is that not so? Then here can be what? Chlorine. And then I can say this is what? CH2. Is that not so? Then CH bracket what? CH3 and what? 2. This is how it is. Now, what is the configuration? It's coming from 1, 2, 3. So what configuration is this one? Arrow or S? Arrow, right? So we say this is the arrow configuration. Now, what do you think would be the S configuration? This one come here and this one comes here. Is that not so? Here will now become what? C. Then we have what? C bracket CH3 bracket what? 2. Here is what? Hydrogen. Here is what? Chlorine. You can represent it with the wedge structure, or you can just draw it like this, CH3. But since you are talking about stereochemistry, what is here? Supposed to be what? Are you sure it's 3? Yes. Yes, supposed to be 3. And then this CH3. Then what do you have here? C. This what? Okay, sorry. This CH3 bracket what? 2 CH then CH2. These are the mirror image. If I want to assign the priority now, here will be what? Number 1. Here will be what? 2. And here will be what? 3. So in what direction is it going to? 1, 2, 3. Is this going? No, it's supposed to be 1, 2. Wait. No. Priority now will not be 1. This is what? Number 2. And here will be what? 3. And this will now be 1, 2, and what? 3. Is that understood now? So that is that. So if it's going anti-clockwise, say what? S. If going this way, what do you call it? Arrow. So remember the law. We go back to the name and call it the way it ought to be. Don't just put arrow configuration. Remember the name of the compound is arrow 3-chloro-2,2,5 trimethyl what? Hexane. So these are the exam questions under this particular topic. Let's go to the next. Now, using an Ingoprelog system of nomenclature, give the configuration of the following compounds: L and alanine. What do you think will be the configuration? Is it arrow or X? Now, let's look at this together. First of all, we need to identify the kind of compound this is. L and alanine is, what is the structure of alanine? What is the structure of alanine? Alanine is COOH. Then we have what? Hydrogen and NH2. And then you have what? CH3. Are you getting it now? So, what will be the configuration of L-alanine? Now, L-alanine means what? It means, now, same way we have D and L sugar, we also have D and L amino acid. Now, let's draw the structure of L-alanine. Now, in this configuration, the COOH group is on top. Then we have carbon. Now, if the NH2 group is at the right hand side, now there are some cases that they may just give you the name and you will be expected to draw and also give the configuration. Now you have L-alanine. Now L-alanine is drawn like this. COOH, C. Here will be what? L-alanine, it means hydrogen is here because you use hydrogen and NH2, and then you have CH3. This is the structure of L-alanine. Now, when they give you the Fischer projection, of course, you know that this is Fischer projection. If I want to draw it, I will draw it as C and then COOH. And here is what? NH2 or H2N. And here is what? H. And here is what? CH3. This is structure of alanine. Now, when they give you the Fischer projection like this, you don't know the one that is dotted, that means pointing away. You don't know the one that is wedged, the one that the highest priority group is supposed to be on. So in that case, what do? You exchange them in such a way that the hydrogen, the lower priority group, will always be under. So what do we do in this case now? This hydrogen will come here. We exchange this. So CH3 will come here. Now, if you are exchanging this, it means you change the configuration. So in order to do that, as you are exchanging this, you also exchanging this. If you exchange it, it means you change the configuration. Then if you exchange it, it means you now bring it back to the normal configuration. So in such a way now, what are we now going to have? We are now going to have C here. We exchange this hydrogen came here, and then this CH3 came here. What are we going to have here? Here will become what? CH3, and then here becomes what? Hydrogen. Then what are we going to have? This one will be exchanged in such a way that this COOH will come here and this one will come here. So here will be what? COOH, and here will be what? H2N. And H2, which is H2N. So what will be the configuration of this? Which of them do you think is the one with the higher priority? Of course, you know nitrogen have higher priority compared to carbon, nitrogen. So here will be what? Number 1. And here will be what? Number 2. And here will be what? Number 3. Now, if they go in the anti-clockwise direction, what would you call it? You call it what? S configuration. So this is S configuration. Okay? S configuration. Now, how about L-glyceraldehyde? Let's look at the structure of L-glyceraldehyde and see how it looks like. Glyceraldehyde is CH2 double bond O then H, which can also be written as CHO C. Then here will be what? OH. Here will be what? H. But because it's L, the OH should be here, and here will be what? H. Then we have CH2OH. Now, what did we say? I say if the Fischer projection, if the normal projection like this is given to you, because the Fischer projection that will tell you whether it's L or what? D. What do you do in that case? Take this one. Let the hydrogen be under. So this hydrogen will come here, this one will come here, and then these ones, they will also what? Exchange simultaneously. So at the end of the day, what are we going to have? You have this, then the hydrogen with a dotted line indicating that it's going away from us. Then what do we have here? In place of hydrogen, we have CH2OH. Then here, what do we have? We have CHO, something like this, CHO, and then what do we have here? Here, this OH comes up here, becomes OH. Do you understand? Now, in this case, what will be our number one carbon? This will be our number one carbon here. So this is carbon number one. And which of them will be number two? Of course, this will be number two. And which of them will be number three? This will be number three. So it is going anti-clockwise. And when it's going anti-clockwise, what do you call it? S configuration. Okay? S configuration. Now, how about D-glyceric acid? From the what is the formula of glyceric acid? It's from glycerol. When glycerol is oxidized and one of the COOH group is protected, it forms glyceric acid, which is this. Now, this is the structure of D-glyceric acid. Now, in this structure, which of them we have to come down? We say hydrogen must be down. So this one comes here. And if this one is coming here, it means this one will go up. And also, this one, they will be what? Exchange. This one will come up and this one will come down. So what will be the structure now? It will be C. That we're going to have. It will be C. Then here, you have the dotted line signifying what? Hydrogen. Then in place of hydrogen before, what are we now going to have? We have our CH2OH, which is CH2OH. Then on top here, what are we now going to have here? OH. And here, what are we going to have here? COOH. Now, in this structure, what do you think will be the configuration? This will be what? Number one. Which of them do you think will be number two? This will be number two. This will be what? Number three. Of course, we say hydrogen is not significant. So 1, 2, 3. And this will become what? Clockwise or anti-clockwise? Clockwise. So this become arrow configuration. So this is how to go about them when Fisher projection is given. Now you see this one here, this other one here was given in the question. Now it was not signifying, but once you put it into the system, it's going to tell you if it is in the L form or what? In the D form. If it's in the L form or in the D form. So what will be the structure of this compound? Or what configuration can we use to indicate this? Is it the D or the L? Let's look at it together. Now it has, not D and L, arrow or X. Now it has already been shown that this is arrow arrow. So how do we know if it is arrow arrow? Now according to what we said, which of them are the chiral carbon center? We agree that this carbon and this carbon are the chiral carbon center because they have 4 different groups around it. Now if we are taking carbon 2, let's say this is carbon 2. If you are taking carbon 2 now as a point of reference, now it means that from here down, anything attached to that place is what? One group. So we can say this is one group. This one here is another group. This is another group. And finally, this is another group. So it has 4 different groups around it. Now, look at them very well. Which of them have the lower priority? Is it not hydrogen? So hydrogen should be down. And if hydrogen should be down, it means that hydrogen will substitute this group here. Is that not so? So it means that this group will come here, and then this group will come here, and hydrogen will come here. Then if this group is coming here, we said that once you are substituting this, it means you are inverting the configuration. And then if you are putting this back, it means you are now bringing it back to the original what? Stature. And what we need to do is put it back to the original stature. But if you do this, it means the configuration will be what? Inverted. So taking hydrogen here and putting it here, what are we now going to have as the structure? We have something like C, then we have carbon here. Then what are we going to have here? Hydrogen. Is that not so? Because hydrogen is coming down. Now, if we have hydrogen there, what other thing are we not going to have? You know that this group here is what? Carbon. Is that not so? This carbon group here, since we are inverting it, this carbon is this carbon we are having here, because we said this group will come here, while hydrogen will come down. Hydrogen has already replaced it here. So it means this entire group will have to come here. Now we have this carbon. Then on top here, what do we have? OH. Is that not so? Then here, what do we have? Hydrogen. Is that not so? Then under, what do we have here? COOH. Is that not so? Now, this other group here, what do we have here? After this group, we now said that this OH group and this carboxylic group was actually what? Replaced again, right? So it means this group here will be what? OH. and then here will be what? COOH. Is that also? So what do you think will now be the configuration? Using the Canning-Goprelog rule, according to what we said, here will be what? Number 1. Then here will be what? Number 2. Are you getting it now? And then automatically here becomes what? Number 3. And here is what? 4. So it's going from right to from like this and clockwise. So that is why this group here is what? R. Is it clear now? Now let us take carbon 2 now and use carbon 2 to illustrate this. If we use carbon 2 to illustrate, what are we going to have? Or carbon 3 rather. We've used carbon 2 to illustrate. Let's use carbon 3. Now this is carbon 3, the chiral carbon center. It means that this group here like this is one group, right? This is another group, this is another group, and finally this is what? Another group. Is that not so? So this carbon here, what do you think it will now be? Now we said this hydrogen must what? Come down. So where is it actually the hydrogen? Where will it replace? To replace this carboxylic group here, right? So hydrogen will come here, carboxylic group will come to where hydrogen is. So we now have something like this. If hydrogen come down, you said it will be represented with broken lines, right? So we have hydrogen. Is that not so? Now the next one is what? The carboxylic group. Where will it go to? Where hydrogen is initially, right? Then this group here will be what? O. Now this OH group will also be what? Replaced. Is that not so? Because we say if we are inverting this one is also what? Inverting. Abi? So this group here will come up, and here will be what? OH. Then we will now have this other group at the corner. This group here, what does it have here? C, right? Then we have OH on top. Then what do we have? Hydrogen. And then finally we have what? COOH. So which of them is number 1? This. Which number 2? This. And this is what? 3. So it's also what? Arrow. That's why we have 2 arrow here. Is that understood? So it's 2 arrow and what? 3 arrow. That is the configuration of this compound. Is that understood? 2 arrow, 3 arrow. Now let's go to the E and Z configuration. Now normally if you have C given to you, if you have, let's say, an alkene given to you, C double bond C, then you have hydrogen here, and then CH3, and then hydrogen here, CH3. You'll be quick to make the judgment that this is what? C's configuration. Why? Because the 2 hydrogens are on the same side and the 2 groups are on different side. Now on the same side rather. If you now have this and then CH3 and hydrogen, and then you have hydrogen and CH3, what would you call this? Trans, right? Now how about compounds that have more than one group present in them? How do you call such compound? Like around the double bond, the groups present are not hydrogen, they have different substituents. How do you call that compound? Now what do we have here? This is Z1 bromo 1,2 dichloroethane. Look at it. Dichloroethane means there's a double bond between 2, right? Now this is carbon 1, carbon 2 of ethane. At position number 1, what do you have? Bromo group, right? So we have bromo group. At position number 1 also, what do you have here? Chloro. Is that not so? Now at position number 1 here, at position number 2 here, what do you have? Let's take this as position number 1 so that we're not confused. Let's say this is 1 and this is what? 2. At position number 1 here, what do you have? Bromo, right? Position number 1 also, what do you have? Chloro, because it's 1 bromo, 1,2 dichloro. So it means at position number 2 you also have another word? Chloro group. Is that not so? So chloro group. And here what do you have? Hydrogen. Is that not so? Now what is the higher priority group? According to the EZ configuration, what you do is assign priority to the both sides. If the 2 higher priority group are on the same side, you call it what? Z. If they are on different group, you call it what? E. So in this group now, this is the higher priority group. Let's say this is A and this is what? B. This is what? A and this is what? B. Combining bromine and chlorine, bromine has higher atomic number. The order of priority is also what? In atomic number, as in what? Arrow and what? X. Is that understood? So this is A and B, chloro, bromine, and then A and B also. The 2 A's are on the same side, so you call it that. Now for the others category, You have E configuration. Now E means just change one of them. You have double bond here, carbon. If bromine is here, chlorine may be here, and bromine will be what? Here. This one, between these two, which one have the highest priority? Bromine. So here will be A, and here will be what? B. Between chlorine and this one, which one have the highest priority? Is what? Chlorine. So here will be A, and here will be what? B. So when the two higher priority group are on different sides, you see this one is down and this one is what? Up. You call it what? E configuration. Is that understood? So let's look at these two compounds very well and see if it is E or Z. Now the answers are already here. If you look at this, divide it into two. This will be what? Between this oxygen and hydrogen, which one have the highest priority? Oxygen, right? And hydrogen will be what? B. Between carbon and this, I told you that the one that have the highest or the longest chain is usually with the one with the higher priority. So this one will be A and this one will be what? B. So in this group now, the two higher priority group are on different sides. So what do you call it? E configuration. Okay? This E configuration. Now how about this? What do you call this one? E or Z? Now between these two groups, which one do you think will have the higher priority? A. Then here will be what? B. Between these two groups, which one do you think will have the higher priority? This will also be what? A, and here will be what? B. So this is also what? E configuration. Okay? Also E configuration. Now let's look at these compounds given to you. Using the same ideologies, you should be able to now talk about distereoisomers. Now distereoisomers are compounds that have two chiral carbon centers. That has how many carbon centers? 2. If you look at this compound very well, I will do just 2, then from there you should be able to do the others. Now if you look at this compound very well, this is what? Carbon here, right? And this is carbon. According to what we said, that if you are given just the Fisher projection, what do? You make hydrogen to what? Come under, right? If you want to make hydrogen to come under in this structure, what do? You say this is what? C. This is your C. Now for hydrogen to come under, which of them are the different group? You agree with me here that this is a different group, right? Now this group from here like this is another what? Different group. And then finally this group and this group are what? Different group. Is that not so? Is that not so? So how do hydrogen come down? Is it not by doing what? Substituting it with this one. If this one come here and hydrogen goes up, I mean if this hydrogen come here and this one goes up, it becomes what? This one now becomes hydrogen here, abi? Then this group will take the position of what? Hydrogen, which is C. Then we have what? OH, H, and then you have what? CH2OH. Is that understood? Now we said as this one is happening here, also this one will also what? Exchange. Is that not so? This group is CHO. That is what you have here. So this OH will come up. If OH comes up, what will become here? This one becomes CHO. Is that not so? So which of them will take position number 1 now between these two? Here will be what? Number 1. Here will be what? 2. And automatically here will be what? 3. And then here will be what? 4. So what configuration is this? Arrow. Is that not so? Now same thing is applicable. Let us do for the second carbon. So we say this one is 2 arrow. Let's see carbon 3. If it will be 3 arrow. 2 arrow. Let's look at this one. According to what we have here on the structure is 3 arrow 2. So this will be carbon. Now if this is the carbon center, what do you think we are going to do? If this is the carbon center, it means this is a different group, this is a different group, this is a different group, and this entire group like this is another different group. Is that not so? Is that not so? Now I'm going to make things easier by indicating this group with what? Let's say, let me indicate this group with M, so that we don't need to write the entire group. Are you getting it? Just looking at it, you should be able to predict if it will have the higher priority or not. So this becomes C. Now what do we have here now? M, right? Let's assume, so that it will be easier for us. What is here? H. OH are what? CH2OH. Abi? Now you are not going to come here. What do we do to bring hydrogen down? Exchange hydrogen with this, right? And then we exchange this with what? This. Is that not so? So what are we going to have? C. Here will be what? Hydrogen. Abi? Then what do we have here? What do we have here at this position? We now have a CH2OH, right? Then what do we have here? M. And here we will what? OH. Now, M is this group here. So don't be looking at M. Be looking at what we have here. Now, between this OH, CH2OH, and H, which one do you think will have the higher priority? OH, right? So this one will be 1. Now, between this CH2OH and this group here, this is carbon. After carbon, you cannot use carbon to identify, so you go to what? Hydrogen. Are you getting it? This is what? Hydrogen here. Why here? What do we have here? Oxygen. Oxygen has a higher priority than what? Hydrogen. So it means that here will be position number what? 2. M will be 2. Is that also? And this one will be what? 3. What direction is it going to? Clockwise. So we call this what? Arrow, arrow. So if you want to call the configuration of this compound, now what do you say? This is what? 2 arrow and what? 3 arrow. Telling you that at position number 2, there is arrow. Position number 3, there's another what? Arrow. Is that understood? Now let's go to the next. Automatically, we know that these two compounds, if you look at them, you see that they are mirror what? Images. Abi? Look at it very well. You see that this compound is a mirror image of this compound. Everything here is the same. Just this one is facing this way, this one is facing this way. So if this one is 2 arrow, 3 arrow, it means this one will be what? 2s, 3 what? S as mirror images. And when compounds are mirror images of each other, what do you call it? Enantiomers. So we can say that these two compounds are what? Enantiomers. Is that understood? These two compounds are enantiomers. Now let's come to this one. Can we also see that these two compounds are enantiomers? This arrow at position number 2. What is here at position number 2? X. So these two positions are what? Are enantiomers. Now this S, what will be the enantiomeric form of it? Arrow. So we can also say that these two compounds are what? Enantiomers. And that is true. Reason being that you have O here, H, and what? OH. So if you ascertain the position, if you can know that of only this one, knowing that both of them are enantiomer, you should be able to determine that for others. So in this case now, let us do for just one and see where it leads us to. Now, where is our chiral carbon center in this compound? This is our chiral carbon center, right? Now, this chiral carbon center, how many groups does it have? 4. Where are they? You agree with me that this is a group, right? This is a group, right? This is another group. And finally, we have this group, right? Let's indicate this group with M. So we have C. What will be here? M. Here will be what? H. Here will be what? OH. What is here? I say CHO. So we indicate this with what? CHO. Now, with what we know, M and hydrogen has to what? Exchange to come down. Then this OH and this have to also what? Exchange. So what are we now going to have here? What do you think we are going to have? To give us what? C. Then OH what? Comes here. And then what? CHO comes here. Then what do we have here? H. And what do we have here? M. Now you are now going to look at them between this OH and this M, and of course you know this is what? Have higher priority. And then this is what? Number 2. And then finally this is what? Number 3. So what configuration is this? Z arrow or S? 1, 2, 3. Z arrow or S? It goes like this, clockwise arrow. So that is the reason why you have this arrow here. Is that understood now? Now the next one is what? Let's consider the next one and see if we have the same thing. If we have what they have here as S, then if you can do that one, it means the other one will be very easy. Now let's look at this one. Where is the chiral carbon center? Here, right? We are the different group. This is a group, this is a group, this is a group, and then this whole stuff here is another group, right? So what do you call this? What are you now going to write for this one? This one is what? C. And then we say let this group be what? M. Then here will be what? H. Here is what? OH. And here is what? CH to OH. Is that not so? So which of them now are you going to exchange for hydrogen? This, right? And then these two will what? Exchange. Is that not so? So this one becomes C. Here will become what? OH. And here will become what? H. Then what are we going to have here? CH2. And here will become what? M. Of course, we know this is what? Number 1. This is what? Number, no, this CH2OH. And this is what? M. M is what? CO. Do you understand? C what? O. Do you get it now? This is CO. Why this one is what? CH. So you are not going to confirm between CO and CH. Which one have the highest priority? CO. So it means that M will have a higher priority as compared to what? CHO. Is that understood? So this one will have the higher priority. So this one will be what? Number 2. And finally here will be what? Number 3. Now note that your M is this group here, not normal M. If you want to bring this out, I will bring it out as COH. Abi? Then what do you have here? H, and then what? C double bond O and H. If you analyze this group, this and CH2O H, we said if the first carbon cannot go, what do? You use the second, right? The second group. It can also be written as CHHOH. Is that also? So this is carbon. This is carbon. They will both cancel out. They can't be used. What do you have here? Hydrogen. Even if you use this hydrogen, they will both cancel out. They can't be used. The next one here is what? Hydrogen. What does this one have here? Oxygen. Or what? Carbon. Do you understand? So which one have the highest priority now? This group. That's why I said M should be what? Number 2. Is that understood now? And then here is what? Number 1. Do you get it? You got it. And here is what? Number 3. So in what direction is it going to? Anti-clockwise. So what do you call it? S. So that is why these ones, they are arrow, S, S. Is that understood? So in this compound now, what do you think will be the configuration? This arrow, this S. Now, if you look at these two compounds very well, you agree with me that there is a similarity between them, right? What similarity can you see? They are enantiomers. Abi? They are what? Enantiomers. And because they are enantiomers, what do you call them? If this one is arrow, it means here will be what? X. If this one is S, it means the other will be what? Arrow. So this will be the structure for this arrow, S. So if you are given any compound now, let's say a distereoisomer, you are asked to name, you should be able to name. So this one now, position number 2, you have 2 arrows. So if you say this one is 2 arrow, this is what? 3 arrow. Why this one is what? 2S, what? 3S. How about this one? 2 arrow, 3 what? S. How about this one? 2S, 3 what? Arrow. Is understood? Is understood? So that is that. Now let's look at the next. Mesocompounds. Mesocompounds. Now, if we look at this formula, I believe everybody now know how to get the arrow, and SS. So at this place, this is arrow, this is arrow. If you look at these two compounds, they are mirror images of each other. Abi? They are what? Mirror image. This one, the OH here, is at the right hand side. Why the OH here is what? At the left hand side. Is that understood? So they are what? Mirror image. What are you looking for? Now, so this arrow, and of course this will be what? XS, according to what we know. Now these are enantiomers. This group here is at the left hand side. So this is the L form, L enantiomer, and this one is the what? D form of it, because the OH is at the right hand side. Now, but if you look at these two compounds very well, what can you see? You see that these two compounds are the same compounds. They are the same compound. Just that one is having the OH facing this way. These two OH are what? Facing this way. And then these two OH is also what? Facing this way. Now, if you divide this compound into 2, you discover that you can also divide this compound into 2, right? And divide this one into 2. If you divide it into 2, you have this part equal to what? This part. This part equal to what? This part. Are you hearing it now? So these two compounds are considered as what? One, and not as what? Enantiomers, because they are the same. They can be divided in such a way that one part will give you the what? Other part. Is that understood? The reason why we could not divide this is if you divide this part will not give you this part. Do you get it now? So these compounds are not considered as what? One. They are considered as what? They are not considered as double. They are considered as what? One. Is that understood now? So that is that. Now look at how it is. This is a mirror image of this D isomer. Are you getting it? This is what? D isomer. This is what? L isomer. So we can say that these two are mirror images of each other. But if you look at this compound very well, what can you see? You see that there's a plane of symmetry running through here, such a way that when you divide it into two, this part is also equal to this part. If you divide it into two, this part is also equal to this part. So we cannot say that this is a mirror image of this. Are you getting it? Because you are the same what? Compound. Do you get it now? If you divide it, it's still what? The same. Do you understand now? So that is the reason why we say these two compounds are what? They are one and not two different compounds, because they have a plane of what? Symmetry running through them. These compounds like this that have a plane of symmetry running through them are called what? Mesostructures. Are you getting it now? So in total now, this compound has how many structures? If these two are combined as one, it means this one is what? 1, this is what? 2, plus this other one is how many? 3. Means that this compound has how many structures? 3, instead of the normal 4, because these two are considered as one because they have a plane of symmetry running through them. Is that understood now? Now, coming back to this again, if you look at this very well, this arrow SS, arrow S, arrow S. Now you agree with me, according to what we said earlier, that these two groups here are what? Enantiomers. Are we getting it? These two groups are what? Enantiomers. But these two groups are also what? Enantiomers. Abi? Now look at this group A and C. Look at A and C. Let's say A and C. Do you see any similarity between them? Are they enantiomers? Look at A and C. Or are they mirror images? Are they mirror images? They are not mirror images. Are you getting it? Because they are not mirror images, what do you call them? You call them distereoisomers. You call them what? Distereoisomers. Is that understood? So these two compounds are called what? Distereoisomer. Are you getting it? They are not mirror images, but they are what? Enantiomers. Is that understood? How about this? What do you call this one? These two, they are enantiomers normally. How about if you look at this one? B and D. How do you call B and D? They are what? Also distereoisomer. They are not mirror images. Are we getting it? So basically, that is all you need to know about isomerism. I believe at this point we've come to the end of this class. What other thing have we not talked about? Let me see. Okay, we've not talked about nucleophiles and the rest. So we are going to talk about them later.